Hi everyone, it's Coach Fred here today, and today I'm going to be going over the quadratic formula. And to get ready for it, I just want to review some simple operations that sometimes get in the way of using the quadratic formula properly. So let's practice simplification. We're going to actually do the ones on the left side, and I'm reserving the ones on the right for you for extra practice. So if you look at -6 plus or minus 18 divided by 2, I want to remind you that that fraction bar is a grouping symbol. And so if we're following GEMDAS, or proper order of operations, we have to do everything within the grouping symbols first. So that would mean the -6 and the 18, you really want to simplify them first. So we would do -6 plus 18 divided by 2 and -6 minus 18 divided by 2, giving me, what is that, 12 divided by 2 and -24 divided by 2, which would give me 6 and -12. So that is something that we kind of have to get used to. And what I'm hoping you see is that, that you could simplify it with the 2, but the 2 would have to belong here and here. All right, looking at the next one, now we've got this power, this square root, and we've got a negative root, and we've got a 4. So we've got all this stuff going on, and we need to be able to simplify this. So first, we're going to deal with this part of the expression. So I'm going to simplify that and make that I times 2 root 5 all over 4. Okay, so let me simplify that a little bit more to make it look pretty. So 4 plus or minus 2I root 5 over 4. Okay, so now if I were to split this up, because I can't really do anything in the numerator because of the I and the root 5, so I can rewrite this as 4 over 4 plus or minus 2I root 5 over 4. So I could split it up. And I could have done the same thing in the top one, chose not to. That's going to give me 1 plus or minus 1/2 I root 5. Now we could write that as root 5 over 2I. Lots of ways we could do that. Okay, more involved situation, which we're going to get, we're going to have to be able to handle with the quadratic formula, is when we have it all going on together. So that square root symbol is also a grouping symbol. So you have to do everything inside it first. You can't take the square root of -5 squared and say it's -5. All right, so we would do -9 plus or minus the square root of 25 minus 5 times 2 is 10 times 3 is 30 all over 4. And so we get -9 plus or minus the square root of -5 all over 4. If we simplify that some more, we're going to get -9 plus or minus I root 5 over 4. 4 does not go into 9, and there's nothing with I that I can simplify it to, so we could leave our answer in simplified form like that. All right, so lots of little things that we have to be careful with. So when we solve quadratics, we want to make sure that we know that we've learned several methods. So we can solve by factoring. We can solve by the square root method. We can solve by completing the square, which is what we just did. We can solve by the quadratic formula, the QF. We can also solve by graphing, which we're going to learn in the next section. So this final method, many of you have said that you've seen before, and I just kind of want to talk about it. We are going to go into where it comes from later on, but for now, let's talk about what you do. So if I want to use the quadratic formula, we have to make sure that the equation is in standard form first. So it has to be set equal to 0. Why? Well, because when we solve a quadratic equation, we're trying to find the x-intercepts, which is when y is equal to 0. So if I gave you a quadratic function, you basically are setting y equal to 0 and solving for x. All right, I really like you to list out your A, B, and your C. You plug them in directly to the formula, and remember, a formula is an equation. So if you don't write that x equals, you're going to make a mistake at some point when these get really challenging. So I'm looking for it as an equation, and I probably will take points off if you don't write it as such. All right, and then you always want to make sure you simplify all roots. So now you're going to be looking for those complex numbers for the square root of -1 or I squared so that you can reduce them. All right, let's try an example. So we have x squared plus x equals 12. We need to get it into standard form. So x squared plus x minus 12 equals 0. Then we're gonna label our A, our B, and our C. So A is 1, B is 1, and C is -12 because the structure says that the coefficients in front of x squared is A, the coefficient in front of bx is B, and then the constant would be C. All right, we plug them right in. X equals -1 plus or minus the square root of. When you put, if there was a negative B value, you're going to want to make sure you put it in parentheses, okay? So, let me mess that one up. So 1 squared minus 4 times 1 times -12 all over 2. And I'll make that simplification, -1 plus or minus the square root of 1 plus 48 over 2. And so x equals -1 plus or minus, I'll write this over 2. This was 49. Square root of 49 is 7. All right, now we see real numbers, nice whole ones, so, or integers, so we wanna simplify. So x equals -1 plus 7 over 2, which is 6 over 2, which is 3. And x equals -1 minus 7 over 2, which is -8 over 2, which is -4. All right, so I have an x-intercept of 3, 0, and -4, 0. All right, so that's how you use the quadratic formula. That's a review. You do have to know the formula. If you're in my classroom, though, you know it's up on the wall. I want you to try number 2, and then when we come into class tomorrow, we're actually going to derive the formula so you guys can actually see where this comes from. Hopefully that helped. Again, do number 2 right now, and we'll check it in class tomorrow. Have a great day.